In this video lecture, we'll learn about humidity control and psychrometry. So first of all, there is a question: what is the largest desert in the world? So this question may arise in our mind. Actually, what is the largest desert in the world? So we may think that this answer would be Sahara Desert or Gobi Desert. Okay, whenever we are talking about any desert, then the thing that comes in our mind, a dry area like a Middle East area or something like that. But you will be surprised to learn that this answer is totally different. The answer is Antarctic desert, Arctic desert, then the Sahara desert. So why actually this is this cold area or this cold iceberg area has become the largest desert? Why? Actually, for this we need to understand the definition of desert. Actually, desert is a place where precipitation, the presence of moisture is too low. Okay, and according to the definition, Antarctica and Arctic region, that is full of iceberg and um, Antarctic and Arctic region, they are full of ice and very low moisture presence. Okay, so this is the thing we will learn this in this chapter regarding humidity and psychrometry. Let's start. So psychrometry is the study of air temperature water vapor relationship, and psychrometric chart is the graphical representation of these relationships, and psychrometrics is the combination of the concept of psychrometry and psychrometric chart. So we are easily understanding that it usually deals with air temperature, air pressure, air humidity. Okay, so first of all you need to learn the properties of air. Dry air means lack of uh, water, and moisture means presence of water. So water vapor is evaporation and transpiration. Airborne impurities include smoke, dust, pollen, bacteria, noxious gases, particulate matters. Uh, there are some properties of air. Air usually follows this rule, as we have learned in our previous courses. Boyle's law, Charles' law, Dalton's law of partial pressure. Now let's learn humidification. It is usually the presence of air in the presence of moisture in the air. Humidification operation involves simultaneous transfer of heat and mass between a gas and a liquid, where the gas is brought into contact with the liquid in which it is insoluble. When the partial pressure of the vapor in the vapor gas mixture is equal to the vapor pressure of the liquid at the temperature, the mixture is said to be saturated. Okay, so whenever something is evaporating from the water surface, okay, any moisture is evaporating, then at some time the vapor pressure of the vapor and the mixture is get equal. Okay, when the partial pressure of the vapor in the vapor gas mixture is less than the equilibrium vapor pressure of the liquid at the temperature, the mixture is said to be unsaturated. Okay, we already know this, and this is scope for further vaporization. So humidity is the water vapor in the air, and moisture is the water in liquids and solid. Humidity and moisture have great economic importance: storage of food and raw materials, optimum manufacturing conditions. So to understand humidification and dehumidification, please take this image into consideration. Under heating, the ocean surface is get evaporated and water gets evaporated from here, and this rise the moisture in the air, and this is called humidification. So the coastal area are somehow very much humid. Okay, for example, our Bangladesh or South Asian area is too humid. Okay, because these are very near to ocean. Okay, but if you consider different uh, regions like desert regions or any um, Antarctic regions, okay, or Arctic regions, you will find less ocean here. Okay, then whenever it is converting into cloud, then it is again coming into the land, and this causes dehumidification. So this is the humidification, the creating of moisture in the air, and this is the dehumidification, the moisture is again condensed into the water. So evaporation of water from the surface of water bodies is to saturate the surrounding air with water, as and when the surrounding air is saturated with water vapor, the water tends to condense in the form of rain. So water in the mud pot is colder than that in steel pot. That is because of evaporation of water from the pores on the surface of mud pot. The evaporation is happening so as to saturate the surrounding air with water vapor. So we can easily understand that what is humidity. However, sometimes these three terms are commonly used: absolute humidity, specific humidity, and humidity. So absolute humidity is the mass of water vapor in unit volume of air, that is mass by volume. And specific humidity is the mass of the water vapor compared to the total mass of the air parcel. Okay, so that is gram per gram or gram per kg. Okay, and that is gram per meter cube. Okay, then water mixing ratio, the mass of the water vapor compared to the mass of the rest of the air parcel. So now let's check this diagram. Whenever any air is being heated, its moisture taking capacity increased. Okay, for example, this is water vapor. Okay, when temperature is increasing, its volume is getting increased, but our droplet size is same, because it will not create much more vapor, it's fixed. But upon the increase of temperature, air volume is increasing. Okay, so whenever air volume is increasing, then air is getting more chance for containing more water when temperature is increasing. Okay, see, this is the air, and water vapor is uh, fully saturated with air. That is why it is 100% humid. But in this case, whenever temperature is increasing, air gains the capacity for gaining more water vapor. Okay, it can gain this yellow colored water vapor. Okay, the area equal to the yellow color water vapor, it can more water in this yellow color. Okay, that is why its relative humidity is half, 52%. And whenever temperature is increasing, then air volume is also increased, but water vapor is fixed. Okay, then what will happen? The relative humidity will decrease. So this is the overall concept of relative humidity. So for better understanding, please look at this. We can easily understand that is 10% relative humidity, that is 90% relative humidity. For example, in all of these cases, humidity is 100%, but moisture content is also 100%, 5%, 10%, 50%. So how this happened? Just think, in a moist area, the air is fully saturated, and this is the moist area, and we can easily understand that relative humidity should be 100%, so that is okay. But here moisture is 50%, but relative humidity 100%. Why? Because it is in different temperature as that of that. Okay, in that temperature, this amount of air can take 50% moisture, and this is its highest capacity. Same, in this temperature, air can uptake only 5% moisture, and that is its highest capacity. Okay, so what does it mean by relative humidity? Relative humidity is mean by presence of some air divided by highest capacity, that is saturated air. Okay, saturated air. So at this moment, at this temperature, its saturation is 5. It can also gaining the 5, so 5 by 5 means 100%. At this temperature, its saturation is 50%, and it is also gaining 50% moisture, so it is 100%. So that is the case. So you can easily understand that actually in the very humid region this happens, and in the cold region this happens. Okay, so this is cold air, and this is humid air, that is dry air. Okay, because dry air has a greater capacity for water uptake. So this explanation has been shown here. You can easily understand by looking at this. All of them are saturated, but all of them are not containing same moisture. This is containing lowest moisture. Okay, and this is the condition of the desert. Okay, this is the definition of the desert, and this is the scenario of the desert. In any desert you will find the air is very dry, and this is the definition of the desert. Okay, whenever you are going Sahara, this case you will found. Then whenever you are going to Arctic or Antarctic region, you will also found this scenario. But whenever you are going to any coastal area like Bangladesh, India, or Indonesia, you will find this situation. Okay, the air is fully moisturized, but in that case the air is very dry, like in Saudi Arabia, air is very dry, and for this region humidification is needed. Okay, and for that reason usually during the Hajj pilgrimage, we see that uh, Saudi government spread air in the road or somewhere else. Okay, so this is the scenario. You can easily understand that this is a cold air. Okay, the air is cold, and the air is money hot. Okay, so let's understand the basic definition. So dry air, and here is the moisture contain water vapor, but in that case it doesn't contain water vapor. So now we need to learn 2 points as we are discussing the dew point and frost point. What are them? Dew point is very important for understanding the air conditioning and refrigeration, because we know in the refrigeration usually water comes out, and by a pipeline we usually drain the water out of the room. Okay, here dew point works. So dew point is the temperature above 0 degrees Celsius at which the water vapor in the gas condenses into liquid water. Okay, so this is above 0 degrees Celsius, and frost point is the temperature at which the vapor condenses into ice. Okay, this happens below 0 degrees Celsius, and this happens above 0 degrees Celsius. This is the main difference. Okay, so whenever, if you just think in any area when temperature is less than 0 degrees Celsius, then you will find out that in that area um, the dew will come out as frost. Okay, the moisture will come out as frost. Okay, but whenever its temperature is above 0 degree, then you will find dew, that is like raining. Okay, according to the measurement units, humidity sensor are divided into two types: relative and absolute humidity. So I have already discussed this: absolute, relative, and specific humidity. These are three important criteria. First of all, we need to learn their basic differences, then we can easily understand. What is absolute humidity? It is nothing but amount of water divided by volume. Per unit volume, how much moisture is present. And relative humidity is the percentage. Okay, is the percentage uh, in regards to the saturated air. And specific humidity is the gram divided by kg. Okay, amount is measured in kg. This is the basic difference. Then it is used for calculating actual moisture content, because within a volume of air you can easily measure this. And this relative humidity is used for comfort, weather reporting, or condensation risk. And specific humidity is used for psychrometric chart. Okay, we'll learn this. So mass of water vapor in a given volume, ratio of actual water vapor in the maximum it can hold at the temperature. Okay, we have discussed this. And mass of the water vapor per unit mass of the dry air. Okay, it measures the actual amount of moisture in the air. That is why absolute humidity is commonly used. Then relative humidity, it dependent on temperature, because at different temperature you will find a different relative humidity. And specific humidity uh, remains constant with temperature and change. And this is the reason why this specific humidity is used in psychrometric chart that we will learn in the upcoming slides. So absolute humidity describes the water content of the air and is expressed in either grams per cubic meter or grams per kilogram. Okay. Absolute humidity is the total mass of water vapor present in given volume or mass of the air. It doesn't take temperature into consideration. And so this is the basic difference between relative humidity and absolute humidity. Absolute humidity in the atmosphere ranges from near zero to roughly 30 gram per cubic meter when the air is saturated at 30 degrees Celsius. Absolute humidity is the mass of the water vapor divided by the volume of the air and water vapor mixture. The absolute humidity changes as temperature or pressure changes if the volume is not fixed. This makes it unsuitable for chemical engineering calculation in drying where temperature can vary considerably. As a result, absolute humidity in chemical engineering may refer to mass of water vapor per unit mass of dry air, known as the humidity ratio. So relative humidity is expressed as a percentage indicated a present state of absolute humidity relative to maximum humidity given in the same temperature. The relative humidity of air water mixture is defined as the ratio of partial vapor of air vapor in the mixture to the equilibrium vapor pressure of the water over a flat surface of pure water at a given temperature. So this is the basic differences. Relative humidity is normally expressed as the percentage, as high percentage means that the air water mixture is more humid. Relative humidity is an important metric used in weather forecast and report, as it is an indicator of the likelihood of precipitation, dew, or fog. In hot summer weather, a rise in relative humidity increases the apparent temperature to humans by hindering the evaporation of perspiration from the skin. So relative humidity is measured in that way. Effect of temperature and pressure on relative humidity. In an open space at constant moisture level and temperature, relative humidity directly proportional to the total pressure. At constant moisture level and pressure, relative humidity decreased strongly as temperature increases. So this is very important. Okay, related to proportional to the pressure, because whenever you are increasing the pressure, it is condensing the air and moisture is present, but whenever temperature is increasing, we have already seen that relative humidity is decreasing. Okay, because air capacity is increasing. In a closed container or fixed volume, relative humidity decreases as temperature increases. Okay, however, not quite as strongly as in the situation of open space. Now let's learn the specific humidity, which doesn't depend on pressure or temperature. That is why it is used in psychrometric chart. Is the ratio of water vapor mass to total moist air parcel mass. Okay, this is the ratio between total moist air. So what is air parcel? An imaginary volume of air to which may be assigned any or all of the basic dynamics and thermodynamic properties of atmospheric air. So we have already shown that in previous slide, that within that air parcel or imaginary area, usually thermodynamics law like Boyle's law, Dalton's law, or Charles' law are applied. Specific humidity is not affected by changes in pressure or temperature. Then learn about psychrometrics or hygrometry are named for in the field of engineering concerned with the physical and thermodynamic properties of gas vapor mixtures. So let's learn the dry bulb temperature. So however, we have used thermometer in laboratory. Okay, so this is a thermometer. So the temperature of a vapor gas mixture as recorded by immersing the bulb of a thermometer in a mixture is called dry bulb temperature. The value of a thermometer is a dry bulb temperature. But just think, when we will enclose this with a moist or wet cloth and will measure the temperature, then it will take into consideration the presence of moisture in the air, and that is called wet bulb temperature. So obviously wet bulb temperature will decrease, will be lower than dry bulb temperature. So wet bulb temperature is the steady state temperature of the vapor gas mixture measured by a thermometer whose bulb is covered with a wet wick or saturated completely by the same fluid. The bulb of the thermometer is covered by a liquid. This, when contacted with vapor gas mixture, the liquid is evaporated by losing its latent heat of vaporization. This latent heat of vaporization is transformed from the vapor gas mixture and loses its sensible heat, and that is why its temperature is decreased than dry bulb temperature. Hence, the temperature is less when the wet bulb temperature is measured. So dry bulb temperature is the temperature indicated by a thermometer exposed to the air in a place sheltered from direct solar radiation. The term dry bulb customarily added to temperature to distinguish it from wet bulb and dew point temperature. In meteorology and psychrometrics, the word temperature by itself without a prefix usually means dry bulb temperature. So whatever we are measuring in our daily life is nothing but just dry bulb temperature. Whenever we are measuring our body temperature, it is dry bulb temperature. Whenever we are measuring any melting point of any substance, then it is dry bulb temperature. Okay, so these are the dry bulb temperature. Technically, the temperature registered by the dry bulb thermometer of a psychrometer, the name implies that sensing bulb or element in fact dry. So we can say here, this is the dry bulb temperature measurement with the thermometer. Whenever we are enclosed this with wet cloth, then it is wet bulb temperature. And this is dew point temperature. Dew actually comes when whenever we are within a glass of ice water. We can see that sometimes uh, this dew is formed. Okay, just whenever we are keeping this in contact with a uh, iceberg glass, then you can measure the dew point temperature. So these are the basic differences. So this is the actual machine for actual thermometer for dry and wet bulb temperature measurement. Okay, now let's discuss the dew point temperature. So just think a situation whenever in the summer season open we often drink cold water from refrigerator. Okay, we open drink cold water. So whenever uh, we discard it, or we um, come this in contact with dry air, sometimes we see that uh, this kind of scenario we see. Okay, water droplets around the bottle. Okay, so actually where did this water comes from? Obviously this is not coming from the inside. Okay, this is our external water. Actually the air which is surrounding our uh, cold bottle, just whenever it is surrounding and going through this cold air, then the moisture come in contact with this cold surface, and whenever it is coming into the cold surface, then it loses some of its heat. And whenever gas is losing some heats, then it is converted into what? It is converted into water. And the heat, by utilizing the heat, this ice is converting into hot air or cold water. Okay, so this is the scenario, and that's why we um, see some water droplets around the bottle. So this is the temperature. This is the dew point temperature when just gas is converting into water. So the saturation temperature of the moisture present in the sample of the air, it can also be defined as the temperature at which the vapor changes into liquid or condensation. Usually, the level at which the water vapor changes into liquid mark the base for the cloud in the atmosphere, hence called the condensation level. So the temperature value that allows this process condensation to take place is called the dew point temperature. A simplified definition to this temperature at which the water vapor turns into dew. Okay, so this is the scenario. Also keep in mind that this dew point temperature is also utilized for the cooling coil. You know, in our refrigerator or AC we use cooling coil. So in the cooling coil of the AC, what happens? The air conditioner takes our air. Okay, what from our exhaled air, this takes our air. Within the coil, what is happening? There is cold refrigerant. So this scenario as like as this scenario, something cold is inside the cooling coil and surrounded by water moisture. Okay, this moisture will be converted into droplets. Okay, and you know, from the air conditioner sometimes we see that a pipe is coming out with water. Actually where does this water comes from? This water actually comes from those uh, our exhaled moisture. So this is the dew point temperature. Okay, so this dew point temperature is important for understanding air conditioning functioning or refrigerator functioning. So this is the temperature at which a vapor gas mixture becomes saturated when cooled at constant temperature in the absence of liquid. When the temperature is reduced further, less than the dp, the condensation of the saturated vapor occurs. At dew point, partial pressure of the vapor in the mixture is equal to the vapor pressure of the liquid. So this is the scenario that I'm wishing to show. So many substances are hygroscopic, meaning they attract water usually in proportion to the relative humidity or above critical relative humidity. Such substances include cotton, paper, cellulose, other wood products, sugar, calcium oxides, and many chemicals and fertilizers. Industries that use that material are concerned with the relative humidity control and production storage of such material. So let's see some other definitions regarding psychrometric process. Another is specific enthalpy. In psychrometrics, the term quantifies the total energy of both of the dry air and water vapor per kilogram of dry air. And specific volume is analogous to specific volume of the pure substance. However, in psychrometrics, the term quantifies the total volume of the both the dry air and water vapor per unit mass of the dry air. Dew point, the temperature which moisture starts to condense out of the air. Dew point is also known as saturation temperature. Dew point temperature is determined by moving from state point horizontally to the left along lines of constant humidity ratio until upper curved saturation temperature boundary is reached. So this is our psychrometric chart, which seems to be very complex. But keep in mind that in this psychrometric chart, the dry bulb temperature is the x-axis, whereas the y-axis is the specific humidity or humidity ratio. Okay, that means gram per kg. Then this curved line are relative humidity line. You can see here that is 10%, that is 20%. This is relative humidity line, and this is the 100% saturation line. You can see this is 100%. Okay. In the meantime, you can see some other vertical line. Okay, this vertical line are nothing but just dry bulb temperature. Okay, this determines the dry bulb temperature, and this horizontal line determines the humidity ratio, these values. However, this point of the horizontal line determine humidity ratio, but this point of the horizontal line determine the dew point temperature. So this is the dew point temperature, this is a dew point temperature, this is dew point temperature. So this line is called dew point line. Okay, then there is some curved lines. Okay, this determines the wood bulb temperature. Wood bulb temperature, wood bulb. So okay, these are the wood bulb temperature. You can see another graph here, which means specific enthalpy. Okay, the heat required or released during the psychrometric processes. Now we'll see this step by step. So these are the dry bulb lines. So these are wood bulb lines. Okay, some angled lines. These are relative humidity lines from 10% to 100%. These are the dew point lines. Okay, these are dew point lines. Just this point determines the dew point, and this point determines the specific humidity. These are the humidity ratio. This point determines the humidity ratio. This is specific enthalpy line. Okay, these are the line. Okay, and this is specific volume line, which is somehow very much vertical than that of wood bulb temperature. So we can easily now understand this figure. Now let's dive into the application of this figure. So here we can understand this is wood bulb temperature, this point. For example, if in any day we found out this temperature. Okay, so what this point actually means? Okay, this point means if any air which having this point in psychrometric chart means its dry temperature would be like that, its wood bulb temperature would be that, with dew point temperature would be that, then its moisture content would be that, then its relative humidity would be that line. Okay, so you can have a lot of data. Its specific volume would be like that. Okay, you can have a lot of data regarding this psychrometric chart. Okay, so these are the chart. You can also find your specific humidity and relative humidity. So these are the dew point lines. So actually I have already shown that this is implied in air conditioner or refrigerator, this process. Okay, because sometimes you need to increase the heat and sometimes you need to decrease the heat. So increasing and decreasing heat means you need to move from here to there or here to there. Okay, so this change will ultimately uh, give rise to a change in specific enthalpy. We'll discuss this later. So now is you can easily understand, if we go from left to right, then it means warming or increasing the temperature. If we go from right to left, that means decreasing the temperature. If we get upward, that means our relative humidity is increasing, that is humidification. And if we get downward, it means drying or dehumidification. Okay, so so uh, energy efficient zone, winter high humidity offsets lower furnace thermostat setting. In summer, lower humidity offsets higher AC thermostat setting. So now you can easily understand, this means heating, sorry, this means humidification, this means heating, this means drying, this means uh, cooling. Okay, so that is humidification and that is cooling. That means humidification and cooling, that is humidification and heating, that is heating and drying, or heating and dehumidification, and that is cooling and dehumidification. So you can easily understand this figure according to the color. So now it's important to learn different terms. First of all, cooling. Okay, sensible cooling. The name is sensible because actually temperature is fixed. Okay, whenever uh, any water is converted into ice, then at 0 degree Celsius it converted into ice, and at that time temperature remains fixed. Okay, so this is called sensible cooling. That means our specific humidity is fixed because our y-axis is not changed, just x-axis value is getting changed. That means our dry bulb temperature is decreased and specific humidity is constant. Dry bulb temperature is decreased, specific humidity is constant. So when actually sensible cooling happens, we know in our evaporator or in refrigerator or air conditioner, we used evaporator coil or cooling coil. So this cooling coil acts by this mechanism. So how? When air passed through the cooling coil whose effective surface temperature is less than the dry bulb temperature of the air but more than the dew point temperature of the air, then sensible cooling is being done. Okay, so that is the scenario that happens in the cooling coil of the refrigerator. You can see. Then sensible heating. This is just opposite to cooling. When air is passed through the heating coil, now it's time for heating coil like furnace. Okay, having temperature more than the dry bulb temperature of the air, only sensible heating is being done. Then humidification. We know from lower to upper region, that is called humidification. So obviously dry bulb temperature is fixed now, but humidity has increased. Obviously, to increase humidity, by increasing humidity, you can do humidification. When air is passed through the spring water, then the water get evaporated. The heat required for evaporation is given up by the air itself. The heat of the air being used to evaporate the water, the air get cooled, but we want temperature should remain constant. So the heating coil is used to overcome the temperature decrease of the air. So what has been said here? Just in some case, you can spring the water. Okay, in the desert region, uh, sometimes in different roads when it is very hot weather, then spray of water is very common picture. So this is humidification. So whenever it is spraying, the water get evaporated and the heat required for the evaporation given up by the air itself. Okay, so given up by the air itself, and that is why air uh, get cooled, because air is providing temperature to what? Air is providing heat to the water to get it evaporated, and air get cooled. Okay, whenever air is getting cooled, but we want constant temperature because we should follow this graph, and at this moment, to increase the air temperature, heating coil is used. Okay, this is humidification, and opposite to this would be dehumidification regarding any use of any adsorbent. Okay, now let's see. So this is the dehumidification. We know this is opposite to humidification. So In the humidification we spray water, but in the dehumidification we will use adsorbent that will absorb water. Okay, then the adsorbent absorb the moisture of the air. It means the moisture get condensed, so the heat is being generated due to condensation. Then the heat get added to the air and hence air get heated up, but we want the temperature should remain constant. So you can easily understand that cooling coil is used to cool the absorbent such that it can overcome the heat added to air. So this is the basic scenario. Now we learn heating and humidification. Okay, so you can easily understand our both dry bulb temperature should be increased and specific humidity should also be increased because it is going in this direction. Okay, dry bulb temperature to be increased, specific humidity to be increased. When air is passed through the spring water, so you can easily understand that humidification means spraying up water and heating. Okay, heating means you should use some heating coil. So both of them are used in this case. The heat required for the evaporation is given up by the air itself. The heat of the air being used to evaporate the water, the air get cooled. You know, during the humidification, air get cooled. But we don't want to cool the air. Okay, we want the heat up so that water is being circulated is get heated by heating coil. So we need to heat the water, and that is why heating coils are used so that temperature of the air don't decrease, it should increase. At this moment air temperature is increasing, also humidity is increasing. Okay, so we need to spray water and also use heating coil. That is the case. Now heating and dehumidification. Okay, so that is you see heating, you know, during the dehumidification actually heating is taking place, as we have already seen in our previous lectures. Like when air pass through the adsorbent, because in dehumidification adsorbent is used, then the adsorbent absorb the moisture of the air. It means moisture get condensed, so because moisture condense into water and come into with the adsorbent. So the heat is being generated due to condensation and the heat get added to the air, hence air get heated and dehumidified. So this is an actual process. During dehumidification, obviously heating took place. So in that case, just think it is going in that direction. You can say. So when enthalpy is needed, enthalpy is needed for any conversion like from here to there, this is the enthalpy. But in that case we are going just in that parallel direction, so it doesn't require any change of enthalpy. So this is the most important thing. During this heating and dehumidification we don't add any heat or remove heat. The process is carried out along constant enthalpy lines. Okay, so no heat is heat changing is occur. Then cooling and humidification. So when it happens just opposite to previous, so it means no enthalpy change occurs. Okay, the air is passed through spring water, then the water get evaporated, the heat required for the evaporation is given by the itself. The heat of the air is being used to evaporate the water gets cooled, also the evaporated water get added into the air, so finally air get cooled and moist. So this is the overall scenario, just opposite to heating and dehumidification. And our last one is cooling and dehumidification. That is very important because this is going to the opposite direction. Specific humidity should be decreased, dry bulb temperature should also be decreased. Okay, so for uh, dehumidification, what do? We usually perform use of some adsorbent. Okay, and for cooling, what do? We use some cooling coil. Okay, when air pass over the coil whose effective surface temperature is less than the dew point temperature, then the dry bulb temperature of the air decreases and also the moisture holding capacity goes to decrease. Okay, and as the temperature of the coil is less than the dew point of the temperature, air cannot hold the moisture, so the some content of the moisture get condensed. This in this process air get cooled as well as get dehumidified. This process is named as cooling and dehumidification. Actually this is happening in our air conditioner. In the cooling coil what actually happens, cooling happens and dehumidification happens. Dehumidification means our moisture is getting converted into water and our room is dehumidified. This is the scenario. So this is the overall summary that we have already discussed. Just go through this. You can easily understand that when temperature would be fixed, during sensible cooling, it is latent heat of vaporization. At that moment, this is equal to, okay, or during sensible heating, this remains constant. Okay, or during humidification, we have already seen that remains constant. Okay, or adiabatic saturation, it remains constant. These are the scenario. But during heating or cooling case, temperature should be increased or decreased. So we can easily understand that humidification is a process of adding moisture at constant temperature. Adding moisture at constant dry bulb temperature can be represented by a vertical line on psychrometric chart. This happens when air at the dry bulb temperature of the entering air is sprayed in the chamber whose temperature is maintained at their temperature. So now we learn different approaches to increase humidity. Okay, we have discussed the mechanism of humidity. Now we'll see the approaches. By adding steam, steam can be added directly in required quantity. Increase temperature slightly. Note favored as impurities in steam can be added at the same time. By spraying water, rate of spray must be controlled so that on completion of vaporization it gives required humidity. By dilution method, air can be mixed with air of high humidity. Now, the dehumidification, we have already discussed that it is accomplished by bringing the moist air in contact with cold surface. Okay, actually, this is happening in cooling coil. Okay, cooling and dehumidification chapter we have learned this. Dehumidifier are used in special heat transfer devices to liquefy vapor by removing the latent heat. Such systems are called condenser. In pharmaceutical industry, many operations are carried out at stated humidity to get optimum result. In many parts of the India, air is very humid and it becomes very difficult to carry on the operation with the hygroscopic substance even in air conditioned room. Hence, dehumidifiers are installed for certain operations. Many sophisticated electronic equipments are maintained in dehumidification conditions. Moist air is brought in contact with spray of cold air whose temperature is lower than dew point of the entering air. These are the approaches of dehumidification. Okay, humidity can be reduced by compressing the air. During compression, the partial paper pressure increases. As soon as it reaches the saturation value, the condensation takes place. The water gets liquefied and drained off. Moisture is passed over a solid adsorbent surface through a liquid adsorbent spray. Dehumidification occurs due to the lowering of water vapor pressure. The adsorbent used are silica gel or activated alumina. The liquid adsorbent are solution or inorganic salts, organic compounds such as ethylene glycol. Reactivation of adsorbents are necessary. It's done immediately or continuously. Silica gel has to be regenerated as soon as or even before it absorbs 40% of its weight of water. So this is the spray of water on moisture. So this is the adsorption of moisture by using adsorbent, and this is the compression of moisture. By just compressing, you are converting the into liquid, and whenever something is converted into liquid, no moisture is present in the air. So what are the applications of psychrometry or humidity? Okay, so for compression of tablet, manufacturing of subgelating capsule, because subgelating capsules, its plasticity or its rigidity very much depend upon the temperature and humidity of the air. So in high humidity, hot, sticky or uncomfortable even at low temperature. In low humidity, throat or respiratory discomfort due to dryness of the moist body membrane, or such weather is known as dry weather. And thus temperature and humidity of the working place must be controlled to ensure comfort of the occupants. Then preservation of pharmaceuticals, the substance absorb moisture and undergo chemical degradation such as hydrolysis, oxidation when they are exposed to excessive humidity. Physical stability of the drugs and dosage forms are affected. For example, gelatin capsules absorb moisture and become soft and sticky. Suppositories and creams become liquid. Low humidity has adverse effect. For example, hard gelatin capsules lose water and become dry and brittle. Therefore, controlled humidity should be maintained. Then evaluation of the doses from like stability study. During stability study, we check the degradation in water. Then processing condition in unit operation like normal drying and freeze drying. Then maintenance of animal and equipment under drug and controlled act. So these are the overall lectures from psychrometry and humidity. under the course of pharmaceutical engineering. If you have any confusion, please inform me in the comment section. Thank you.